Okay, let's look at two more examples, and then we'll be finished with section 10.1. Last two are a little more complicated. This one's not too bad, but it is a fourth degree polynomial. So let's get started. First step, find the derivative, okay, which is what? 4x cubed minus 8x. Second step, set first derivative equal to 0 and see if you can solve for x. Yeah, we can do that. We can factor out, what, a 4x, and then we'll be left with what? X squared minus 2. So we're going to set each of these expressions equal to 0 and solve each of these two equations separately. Okay, so this one would be x equaling 0. This one would be what? X squared equals 2. So therefore, x will be plus or minus. It's quadratic. So I'm taking the square root of both sides, but I'm remembering it's to the second power, so it's plus or minus radical 2. All right, so all of these are critical numbers. So we have negative radical 2, 0, and positive radical 2. All right, let's create a number line and let's figure this out. So there's your number line, negative radical 2, 0, positive radical 2. We want to look at the sign of f prime of x. We're going to do that by coming up with test values down here. So negative radical 2 is what? Negative 1.732, so negative 1.7. So maybe use negative 2. And then maybe use, what, 1? Or excuse me, negative 1. And then positive 1. And then positive, I don't know, positive 2. That'll work, wouldn't it? Okay, so, well, let's go through this. If x is negative 2, what's going to be the sign? So just take your time, and you're going to plug in these test values into the first derivative. Okay, so let me do this real quick. Separate this number line into 4 distinct intervals. All right, so if it's negative 2, what are we going to get? And you can use your calculator for all I care. Doesn't matter to me. Plug it in. What do you get? Well, negative 2 cubed is what? It's negative 8. 4 times negative 8 is negative 32. Negative 32 minus 8 times negative 2, well, that's positive 16. You're going to end up with a negative, right? Negative. Okay, negative 1, you get what? 4 times negative 1, negative 4. Negative 8 times negative 1 is positive 8. 4 plus 8 is positive. All I'm doing is replacing every x here in the first derivative with my test value and determining the resulting sign. If x is 1, you get 4 minus 8. That's negative. If x is 2, you get what? If x is 2, you get 32 minus 16, right? Which is positive. So now I have my signs. What's going on? You're going down, then up. Here you're going up. This is all going up, this interval. But I'm just focusing in on what's going on right at this critical value. And then you go down, and then you're down here, and you go up. So we're going to have 3 different points, right? So f of negative radical 2 equaling something will be a what? Down, then up. So because you're going down first and then up, it's going to be a relative what? Minimum, right? Okay. And then also f of positive radical 2 is going to be a relative minimum. Same reason, down, then up. And finally, f of 0 will be a relative what? Maximum, okay? Because you're going up first, down second through this critical number 0. All right, to determine what the value would be of f of negative radical 2, you simply replace every x in the original function with negative radical 2. All right, so if you do that correctly, what are you going to get? Well, negative radical 2 to the 4th would be what? That'd be 2 times 2 or 4. And then minus 4 times negative radical 2 squared would be 2. So 4 minus 8 is what I'm getting, which would be 4 minus 8 would be a negative 4. And the same thing for this one. Again, these corresponding y values, if you need to use your calculator to determine what they are, that's fine. Finally, if you're looking at f of 0, you would just get 0, right? So the ordered pairs would be negative radical 2, comma, negative 4, radical 2, comma, negative 4, and then the relative maximum would be at the origin, the ordered pair 0, 0. Isn't this fun? Final example from section 10.1. First step, same thing, got to figure out the derivative. Oh, but look at this function, this is interesting. Could I use the quotient rule on this? Yes. Could I even bring up this x into the numerator and use the product rule and chain rule? Yes. Or we could remember what happened way back in section 9.4. And that is, if you have a sum or difference of multiple terms on top divided by a common denominator, you can rewrite this to make it much easier than using the quotient rule or product rule or chain rule by just simplifying. X over x is just 1. And then positive 1 over x is 1 over x. Now, 1 over x is the same as x to the negative 1. So this expression means exactly the same thing as this expression. Now I'm ready to differentiate. Same idea. F prime of x is equal to what? Derivative of 1 is 0. And the derivative of x to the negative 1 would be what? Negative x to the negative 2, which is exactly the same as negative 1 over x squared. All right, now we set this thing equal to 0, and we solve for x. Well, if I were to multiply both sides of this by x squared, you get 0 equals negative 1. That's not true. So therefore, there are no x values that would make the first derivative equal to 0. However, we're looking for critical numbers. So not only are we looking for x values that could possibly make this first derivative be equal to 0, we're also looking for x values that could make it undefined. And if you notice, you have a variable x occurring in the denominator. If you were to solve for x, you get plus or minus 0, which is simply 0. This value is, yes, a critical number that would make the first derivative undefined. That's why it's a critical number. So we're going to use this. All right, so let's go through the motions. We're going to look at the sign of f prime of x on top, like we've done. This is the 8th time we've done this, okay? And then test what? 0. Well, not 0. We're going to plug a 0 in there on our number line. This is our critical number. Okay. Let's come up with test values. X may be negative 1. X may be positive 1. All right. All you're going to do is the same thing we've been doing 8 times. Plug in negative 1 into first derivative and determine the corresponding sign. So if x is negative 1, you square it, you get positive 1. What's a negative divided by a positive? A negative divided by a positive is a negative. You all know that. What if x is 1? What if x is 1? Oh, look at this. If x is 1, you get negative 1 divided by 1. Oh, you get a negative again. Oh, that's interesting. So this thing is going down from left to right as you go through this undefined region. And then as soon as you go to the right of this critical number c, where it's undefined at 0, it's going down again. So do we have a situation here where it's either going up first, down second, or do we have a situation where it's going down first, then up second? Do we have either one of these? No, it's going the same direction. Okay, it's decreasing both ways as you approach this 0 from the left and then as you go past the 0 on the right. So what does that mean? Therefore, the function f has what? No relative extrema. F has no relative extrema. All right. Hope you guys are having fun and staying safe, and I'll see you again real soon. Take care now. Bye-bye then.